All right, hello everybody and welcome, and thank you for attending the OpenShift on-prem webinar to talk about OpenShift as you're deploying this on-prem. This is brought to you by Crossvale and Red Hat co-hosting this together. My name is Todd Millard. I am the CEO of Crossvale, and with me presenting also is Patty McMahon, which is one of our principal architects that expert in this space. We're going to get rolling here, and we'll walk through the agenda, and then also at the end have a little bit of time available for if there's any questions. So please use the chat to ask questions, or wait till the end and we can get some questions answered for you. So first, I'll just give you a quick overview on Crossvale, just 30 seconds here, so you know why we're here and what is bringing us to the table to talk to you about this. So we've been around 22 years. We offer a 24/7, 365 support for solutions that we service for Red Hat, such as OpenShift is a major solution that we're managing for customers worldwide. We have operations in Dallas and Belfast and Barcelona, and then we also are a 5-time award winner for Red Hat awards, including Container Platform Specialist of the Year. We've been Partner of the Year. We're also part of the Apex Premier Partner Program, as well as Container Modernization Badged Partner for AppDev. So glad to be here to talk to you about how we can help you guys with your current situation on OpenShift on-prem. So why containers are a must-have will be the first part of our discussion here. Then we'll walk through an overview of on-prem OpenShift, kind of talk to you about some things that will be helpful to know as you're thinking about deploying on OpenShift on-prem. We'll also talk about why DIY is hard, like why people end up needing some help in this space as they're walking through changes in this new paradigm of modernization with containerization. And then we have a solution on how to simplify the problem for you in a way that's cost effective and can help accelerate your results. So that being said, we'll get rolling into our first segment here, why containerization our containers are a must-have. So understanding the problem, container competency is not optional. So as we're moving into the early majority here in container competency, this is now getting to the point that this is not something that organizations need to think about. Do I need to do this, or is this something that we're going to do? It is now at the point that it's not optional. I'm going to explain to you what the meaning behind that is. The big push behind this is, if you think about what you're thinking about needing containerization for, the COTS providers out there, the commercial off-the-shelf software providers, also have thought about the same things. More agility, being able to get things done faster, compartmentalizing their solutions down into microservices, so testing is easier. They don't have to have long deployment cycles. They can deploy every day. All of these things, that's the same reason why organizations look at containerization. The commercial off-the-shelf software guys are looking at it too, because it lowers their cost of operations. So every COTS provider at some point will move to containers. And then if you are using commercial off-the-shelf software, you will need to have a competency in this space. And there's a lot of different ways you can do this. Obviously, you can go into cloud, you can go on-prem, different solutions that are around there for different things that you're trying to do in containers. But you're going to be forced into having container competence if you use any type of COTS providers. So what happens is, like, here's an example of some different types of COTS solutions out there. Some EAM, AI tools, warehouse management systems, ERP, supply chain management. Obviously, those of us that are in IT, there's no shortage of solutions out there you can buy off the shelf. What the COTS providers do first, and this is what you should take a look at in your own ecosystem. Do I already have COTS providers, things that I'm buying from somebody else, it's a third party, that they're offering to me as a container? So I'm still deploying it in VMs, but I have a choice today. Can I deploy their solution in containers? Because this is important, because this is the very first step as we look at over the years, as people have started adopting containers, what first happens is they containerize it and they start offering that as an option. So now at this point, their operation cost is going up because now they have to maintain all the different dependencies in the VM type delivery, and then they're also maintaining the container side of this. So they're motivated to move their customers over into containers so they can get rid of the other side of that where they have dependencies tied up in VMs. So what ends up happening is those commercial off-the-shelf software or tools that you're using that are offered in container, they end up going to end of life the non-container version. So this means the time starts ticking for you where you have to say, I'm going to take this as a container. And why is that important? Well, because once the version passes that now you must be in containers, now your security team starts getting involved because they start going, well, we're not getting the patches. Why are you on an old version of this solution? This is a critical workload or a workload that we really count on, and we need to make sure we're getting proper security patches on that. We all know how that works with the security team wanting you to make sure that everything's secure. So getting ahead of this, should I be container competent, is super important today to have a plan in place and how you're going to solve that problem. Now, this is why I'm saying it's not optional. Now, obviously, there's a lot of other things that people have already, the early adopters and those in the early majority have done in containers. There's outside container or commercial off-the-shelf software. There's plenty of things with your own applications where you can improve upon how you're managing those applications and getting more out of your infrastructure in those applications and being a lot more agile and really using DevOps in a way that's going to really accelerate your business. So IT, instead of being a cost center, becomes something that's driving revenue because the business can now be very agile and changes. So that's another side of this, which also is a reason why the COTS providers are super motivated to move this direction. If we take a look at the containerization growth rate projections over the next 10 years, we're here in 2023. And this is broke down across North America, Europe, Asia Pac, South America, Middle East, all the size. And as we take a look between now and 2030, this growth path for containerization. And as I said before, as the COTS providers and people that are using application development to drive their business are becoming more and more understanding of how containers can help solve their problem, more and more adoption will be done. So this means you're going to need to have a solution. Go out there, get resources, train them, continue to hire, develop the skill sets internally, use a managed service to provide this for you, do a hybrid approach where you maybe have some resources inside and you have some resources where you're using consulting or a managed service or some cloud solutions or, so there's a lot of different ways to solve this problem. But as we take a look at the growth path, the problem is here and it's going to continue to grow. It's not going to be something that is going to go away. And the biggest risk in DIY shops is that the lack of experienced enterprise architects that understand containerization can cause you slow adoption. And this is a sweet spot for Crossvale. One of the areas that we excel in is organizations that have either no enterprise architects or a very small handful of enterprise architects that are usually very talented at what you already do. But when it comes to moving to this new paradigm of containerization, there's a big learning curve and a lot of processes that have to change. And we've done it many, many times with other organizations, and we help accelerate you through that solution, whether you're deploying on-prem or in the cloud or using a SaaS container solution. We've done it all. So now I'm going to move on to an overview of on-prem OpenShift. I'm going to pass off to Patty McMahon, who is talented in this space, one of our very talented principal architects. And then I'll come back on a little while later and talk a little bit about DIY and simplifying this problem.
Cool. Thanks, Todd. So I'm just going to kill my camera here, just to save on some bandwidth and make sure everybody can hear me. I promise I'll come back on after I'm finished. So yeah, let's talk about OpenShift on-prem. And in the next couple of slides, I'm going to go over some of the advantages, disadvantages, the pitfalls, things to watch out for. And I'm going to bring up some technical situations that we as Crossvale have found ourselves in, how we've approached those, and the challenges of how we got around those challenges. So first off, OpenShift is extremely flexible, which is good. It means it's available on many platforms and it can fit many use cases. However, as noted here in the slide, with this flexibility, naturally complexity increases. And when it comes to on-premise deployments, we have lots of options, and we can deploy to bare metal, VMware, deploy to Rev, OpenStack, anything that you have sitting in your data center that RHEL or Red Hat Core OS can run on. Generally, we can deploy OpenShift onto that. And while there is a general approach for installation, each platform can have its own specific infrastructure requirements, configuration, and install methods. So let me give you an example of this, and let's overly simplify the deployment of OpenShift. So we want to deploy 3 control plane nodes to manage our cluster and 3 worker nodes for our application workloads. So we need a few key things. We need a Red Hat Core OS image. We need some ignition config, and that effectively defines how our nodes are built and configured. And we need a connection to a registry to pull some container images, which makes up the OpenShift cluster. And let's say we want to deploy to VMware and we want to deploy to bare metal. So with OpenShift, it can leverage a lot of the features of VMware. So we can utilize VMware templates. We can take our ignition config and we can embed that into those templates. And once we build those VMs, an OpenShift cluster will automatically get built. And that's good on VMware and vSphere, but this install process won't work on bare metal. On a bare metal install, I'd use the same ignition config, but it's provided maybe via an alternative method via Pixie or a custom-built ISO. And in addition to this, you probably need to configure additional settings in your bare metal nodes, like bonding of network interfaces, things like that. So as you can see, depending on the platform, and this is a small example, but depending on the platform, we have different methods of installation and again, increased complexity. In addition to this, we need to think about the environment around OpenShift and the prerequisites and the install needs. Again, let me give you another example. Nodes that boot for the first time, they require IP addresses. OpenShift likes to have DHCP servers to do this. However, a lot of on-prem installations that we do and a lot of companies that we engage with, the process of setting up a DHCP server can take weeks, if not months, and you'll get a lot of pushback from networks or security. So again, you can find yourself passing kernel parameters into ISOs to temporarily configure NICs and download ignition config. All of this, again, adding more complexity to your install. So just one point that I also want to bring up here is UPI or IPI, and it's pretty simple to understand the difference between these. So UPI is user provisioned infrastructure and IPI is installer provisioned infrastructure. So UPI essentially means that you provide the infrastructure to the OpenShift install or to the OpenShift cluster. So you're building your own compute, your own load balancers, networking, storage, things like that. And then the installer will just deploy on top of what you've provided. IPI is installer provisioned infrastructure, meaning that the OpenShift installer will create all of the underlying resource it needs. again, compute, load balancing, even create records in DNS. But what we find is the API install method is highly opinionated and assumes a lot of environment prerequisites that have already been taken care of, e.g. a DHCP server. So while API is an extremely easy method to set up OpenShift, we rarely see it on-premise installations. Generally, we have to take full control of the install process and deploy via UPI. And because we deploy via UPI, that brings lots of other things, let's say, into the install method, such as Terraform or Ansible to deploy your infrastructure as code. Todd, just next slide there. So once we've selected our platform, next we need to select our storage provider. And again, OpenShift is flexible. It can integrate with lots of platforms, and by extension can integrate with lots of storage platforms as well. So iSCSI, Fiber Channel, Ceph, Portworx, TinTree are all a few examples. There are tons more. The more vendors that release integrations into OpenShift, again, that number just grows and grows. So there are pitfalls to watch out for here too. And the first thing to cover is what type of storage do we need? Will block storage do? Do we need file or object storage? And how many pods need access to our storage at the same time? It's worth noting here, so OpenShift defines storage in 3 different categories. So RWO, which is read, write once, ROX, which is read only many, and RWX, which is read, write many. So RWO, read, write once, is quite interesting. It doesn't mean only one pod can access the storage at the same time. It means one node can. And that means you can have multiple pods accessing the same storage device, but they all have to live on the same node, which defeats the purpose of having multiple nodes for high availability. Read-only many and read-write many means multiple nodes can access the same storage device at the same time, which gives us better high availability, and pods can spread across multiple nodes. But again, your storage provider has to support this. So for instance, if you use Fiber Channel on its own, generally you can't use read, write many. You can only provide block storage, which is severely going to limit what you can deploy to your OpenShift cluster. So with RWO, it's just not good enough to only provide that type of storage when building an OpenShift cluster. It will work, but it's going to severely limit what you can deploy to OpenShift. And a lot of software that is getting built now or is provided as an operator within OpenShift all require these read, write many storage types to function because they're all running in a high availability setup. Todd, next slide, please. Next then is our networking. And to be completely honest, a lot of the on-premise deployments that we do are deployed to a single private VLAN, and network complexities are handled outside of the OpenShift environment. But there are scenarios and use cases that have come up to complicate things. For instance, some customers run a production network on a DMZ network. They run their applications in the production network and their API management in their DMZ. So if we wanted to bring that setup into OpenShift, suddenly we've got a few questions that we need to answer here. So do we run 2 separate OpenShift clusters, one on our production network and one in the DMZ? Or can we run one cluster with a few nodes outside in the DMZ? So either option is fine here, but generally it's better to reduce operational overhead and run the one cluster. But now, as you can see, we have nodes in our production VLAN and we've nodes out in our DMZ VLAN. Our control plane sits in production. How is it going to communicate with nodes out in our DMZ? And then all of a sudden, we're bringing in all of our switches, our routers, our firewalls, ports need opened, all of that traditional good stuff needs to be thought about, designed, and configured to run a setup of nodes across multiple subnets. In addition to this, we need to understand how we're getting traffic into the OpenShift cluster. And the way we typically do that with on-premise is that we have some form of load balancer, Citrix NetScaler, an F5, something like that. And it sits outside OpenShift and sends traffic to the OpenShift ingress pods. But we also have the option to run our load balancing within OpenShift as well, and just have a DNS record pointing to OpenShift. And OpenShift manages all of that load balancing itself. So there are a lot of options there. You need to go and understand them all, but only you will really understand what's best for your business. But Crossvale, we've done a lot of this, so we can lay all of those options out. In addition to this, a final note rather, is on the software-defined network within OpenShift. And the software-defined network basically allows pods and services running in the OpenShift cluster to communicate with each other without really having to leave the cluster. But again, OpenShift is flexible. It integrates with a lot of third-party software from vendors or things that Red Hat have provided. So again, there is many SDN plugins that you can utilize. So there's things like Cisco SCI, Flannel, or NSX from VMware, are all examples that we can plug in to OpenShift to increase the capabilities of the software-defined network, increase our monitoring and management capabilities of our software-defined network. So next slide, please, Todd. So finally, I just want to go over something that we at Crossvale have done. I realize obviously a lot of the design decisions that go into OpenShift or go into an OpenShift deploy, like platform, network, and storage, are being simplified here, but generally the core principles are good to consider. So yeah, let's look at an example here, and this is a real world setup that Crossvale had to deploy and had limited access to. So we have a basic setup. We have a bastion or jump box that we can connect to. A requirement is to deploy OpenShift cluster with 3 control plane nodes and 3 worker nodes, 3 storage nodes for OpenShift data platform. We're deploying to bare metal and we have access to some sort of FILO or iDRAC interface. We don't have DHCP. We're deploying to an air-gapped or disconnected environment. Basically, we have no access to the internet. All of this is sitting in a data center hundreds of miles from us, and we need to deploy OpenShift. So let's quickly run through the install process for this. And bear in mind, this probably is more of a corner case and one of the more difficult installs that we have faced. But nevertheless, as security compliance and policies grow and things get more restrictive, these installs tend to start to appear more often. So we need to install Red Hat CoreOS first of all. So we download the ISO and we place that onto the jump box. We have generated some ignition config using our OpenShift install command, but it needs to be available at boot time to our Red Hat CoreOS nodes. So to make it available at boot time, we need to then build a HTTP server on our jump box to host the ignition config. And then we get into the situation where, okay, we have ignition config and we have Red Hat CoreOS images, but they're completely separate from each other. And how does Red Hat CoreOS know what to talk to? So next we have to unzip our Red Hat CoreOS ISO, and we have to start modifying boot parameters and kernel parameters to configure things like static IP addresses, net masks, gateways, and then finally we have to tell Red Hat Core OS where to get its ignition config. And then we think we're ready, but let's wait. This is only one ISO and we're building 9 nodes. So then next we have to write some Ansible to automate the generation of these ISOs and then host these on our HTTP server. So that's all good. We think we're ready. We've got Red Hat Core OS. We've got our ignition config as well. So then let's configure all of our bare metal instances to configure, to reach out to our HTTP server to download our ISOs. And every server has its own URL, so it can download its specific ISO, which will allow it to connect to its specific ignition config. So it's classed as a certain node. So it's a control plane or a worker node. But before we can trigger all of this, we're in a disconnected environment. We've no access to the internet. We've no access back to Red Hat to gather, to get all of our install images. So what do we have to do? Well, we have to build a registry that will house all of our container images. So we build a container registry. We mirror all of our release images into that registry, and now we're ready to go. But then we also need to consider storage. We need to ensure RAID is all turned off on all of our servers, so that it will work with ODF. So if we follow all of those steps, and this is very much a corner case of one of the more difficult installs that we've done, we do end up with an OpenShift cluster. But be aware, if you don't finish all of these steps within 24 hours, your certificates will expire in your OpenShift ignition config, and you need to regenerate everything again. So it can get quite complex. Next slide, please, Todd. So yeah, I realize probably a lot of things said there are quite complex. They are quite technical, and maybe you won't get a full picture of it, in a 15-minute webinar. But what I'm just trying to say here is on-premise is complex, but it's a lot of the complexities are based off of your environment, off your policies, your security considerations, and anything really that your enterprise needs to be specific to your environments. So with all that being said, however, just don't let the complexity deter you. OpenShift on Kubernetes, once it is deployed, once it is set up, a lot of the rewards are there. I've listed a few here. So auto healing, auto scaling, increased density, and increased security are just to name a few. But it is worth it. So thank you. Over to you, Todd.
All right. Thank you very much, Patty. I appreciate that. Yeah, as we sit here and we take a look at the complexity of Kubernetes, and we take a look at OpenShift, and we work a lot with OpenShift because, when it really comes down to it, if you're looking at trying to simplify your solution of moving into containerization, OpenShift is the best containerization platform on the planet because of the ability to do all the things that it does, all the options that you have for it. But that being said, we move into kind of a discussion around when moving into containerization, why DIY is hard. Do it yourself. And what we've run across with organizations that are being forced into containers or needing to get this container competency, whether they're using OpenShift or going cloud, or running OpenShift in the cloud, or running raw Kubernetes, or whatever it may be. These are common problems that we've seen in organizations that either are in the middle of their container journey, or as they're starting to take a look at how they're going to solve this, but limited resources. So in the marketplace out there, it is it's hard to find the resources that have the skill set to do this at a very high level. So, and the other aspect of that is then when you go get resources, train them, invest in them, now all of a sudden they're more talented and open to being stolen by other companies that are looking for those kinds of resources. So resource limitations is a big part of the DIY for do-it-yourself. Lack of technical expertise. So most organizations we run into when they're moving into a new paradigm like this, they don't have the expertise and they end up having to reinvent the wheel. So they're trying different things because they don't have the right technical expertise, or they go hire the technical expertise and either through consulting or through recruiting and pay high costs for doing that. Operational complexity. So we just talked about the complexity of install, and we talked about all the values that you get out of it. There's a lot of benefits to it, but you still have complexity in and again, this is across the board. OpenShift simplifies the operational complexity a lot. It's the best one on the planet for that, no matter which Kubernetes platform you go into, and even whether you're going into a cloud provided one. There's a lot of things that are going to change operationally that you're going to need to be aware of, and having somebody that can come in and accelerate this for you, that has a framework to solve this problem for you, but also understands what the operational how to integrate it into your operational needs, it can solve a lot of problems for you. Integration with existing systems. Just because the clusters stood up doesn't necessarily mean that's where it ends. It's all, how do we tie this all into your ecosystem, and what works and what doesn't work, and what different choices are out there and different options are out there. There's a lot of ways that you can do this by leveraging wisdom of others that have been there before you, and finding an organization that understands how to navigate you through that. With Red Hat and Crossvale, been there, done a lot of that stuff in the past. DIY is also hard because scalability concerns, trying to understand how to deal with a more dynamic environment than a more static environment, what that does to change things in your organization. Security. Also, how do you deal with a new, different type of security of securing containers? And what does that mean for your organization? And how do you get to a point where you can be confident very quickly and not feel like you're still trying to learn security? Migration issues. Okay, what do you do with your applications? How do you migrate those applications? Do you need to rewrite those applications? Can they just be lifted and shifted? All of those are concerns that can take a lot of time and effort and energy to get you where you need to go. But again, once you get them in and you start getting the value out of them, the value of doing the migration pays off, but there's work involved to get there. Change management as well. Adopting OpenShift often involves significant changes in your organization. How do you work through those changes? Half of this problem is a technical problem, but half this problem is a process and operational problem. Like, how do you change the organization to be able to fit the new paradigm while you still have your technical debt or your prior systems that have been in place, and how do you implement all that? There's no one size fits all. Everybody's different. Everybody has made different choices, and how do you integrate this in a way that's going to make the best sense for you? So maintenance also becomes one of the great things about OpenShift, and why it is the best container platform on the planet, is because of all the projects that they bring together and support for you. But also, that means there's skills that if you're going to DIY this, that you're going to need to have resources to understand all these different projects. And if something goes wrong or something's not working right, understands how to troubleshoot this and ask the right questions to be able to Red Hat for your support. So understanding all these different things in relation to monitoring and networking, your security, your developer services, how it works with virtualization, if you're using Edge, application services, how is this working, with the underlying OS? All of these things are areas where having these skills are going to accelerate you tremendously. And getting those skills can take some time and energy. And this is why we see there was early adopters that got in because they developed these skills or had these skills, and then why we're kind of in the early majority now, where people are going, it's take me some time to develop these skills, or I'm going to go out there and use consulting or buy these skills somewhere. So how do you simplify this problem? You know, there's big values on the back end of this. There's being forced into containerization, you know, and trying to do it yourself. There's a lot of decisions along the way that you have to figure out how to make on your own. But there is a simpler way to solve this problem. And what it is PodOps Pro for OpenShift. So this is a service that Crossvale, having worked in this space for more than 5 years, we understand all aspects of this, from the build of it all the way through operating and application development. We've spent years developing applications for companies over the years. So what PodOps Pro does is brings you continuous container workload assurance. So this is a 24/7, 365 service, saves you 43% over DIY and 900% increase in time to confidence. So what we find is having continuous container workload assurance gives you that peace of mind that your cluster maintenance is going to be taken care of, which is not the hardest part of this. There's a lot of services out there that you can get cluster maintenance. Rosa is available, ARO is available, which are services that are OpenShift services in the cloud that handles the cluster maintenance for you. And we actually wrap our PodOps service around those people that want to use those services. The big issue here is, how do you deal with the dynamic changes that is happening in your workloads and how it affects the clusters, and understand how to make decisions as the cluster dynamically needs changes, because now you're not working with a static environment. You're working with an environment that changes, but you're getting huge value out of that. But there's ways that you think about this the old way that you used to think about it, very statically, and then your costs go up, your value goes down, and it ends up becoming a lot more difficult for you. So what PodOps for OpenShift does is we provide you platform confidence. So run it anywhere, deal with configuration drift, operationalization, maintenance, patching. The subscriptions can be included, or you can bring your own subscriptions if you already have them. Workload excellence, so dynamically tuned, custom telemetry, workload onboarding support, resource management. All of that stuff is all a big part that's very difficult for organizations, is that area above the cluster maintenance, but below where the app dev team is working on these. And how do you make sure you get the most performance out of the applications that are running in your cluster? We found, as we even went into very mature customers that have been working in containerization for years, there's usually a lot of value that can be brought to the workload excellence part of this. And that's what you're really looking for when you go to containerization. You want your workloads to perform better than they're performing today. And then you're going to bring your domain outcomes. So the things that your team is going to run in the cluster and understand how that domain outcome is going to help your business, we're going to interact with your teams to enable them to get the type of domain outcomes that they're looking for, and understand the changes that they need to make in their applications or COTS solutions to get the best workloads. So we bring subscription compliance. We understand how to get you the right subscriptions that's going to get you everything that you need, as well as choose your infrastructure. Running on-prem is a bit more complex. We know how to do it, even in the most complex way. Like Patty had just talked about a very complex on-prem deployment. Like, we have the skills to be able to simplify that for you. Scoped custom build. So everybody's different. We understand how to come in and ask the right questions to get you the right build so that you get exactly what you need. Operationalization, we bring our own templates. We bring our own operational guidelines and then integrate that with you, as well as integrate that with your ITSM. Cluster maintenance, we're handling the cluster maintenance for you. Telemetry, proactive automation as well. So we bring our own proactive automation that we've built in customers over many years to be able to simplify your operations. And we have pre-built telemetry that we bring in, so you don't have to figure that out. Workload onboarding, we're there step by step with your team, understanding what's going to happen with that cluster before it happens, so that we can give you advice on what you need to do, so you're not taking the cluster down when new workloads are coming on to the cluster. And dynamic tuning. As things are changing, how do we dynamically change things and work with you so that you get the best value out of the cluster? And then we mentor your team. So we're spending time with your team, each month as they're trying to learn how to improve this and understand how to make dynamic decisions. The key here is you want to understand how to make the decisions, not be given a checklist that says, hey, these are the things that I need to do, because it's the dynamic decision making that's going to get you the huge value out of moving to containerization. So we reduce your time to confidence by 900%. So we can get you confident in your cluster in less than 30 days. Most people, it takes 9 months from when they start to get to the point that they really feel like they can run their critical workloads. The operations team is the one that's going to slow you down. They're going to say, no, I don't want to be the one holding the bag here if something goes wrong. So I have to be fully confident. So I have to know everything. We bring that to the table. So day one, you're fully confident and we're your safety net. Reduce time to start. So we can get you started in just a few weeks rather than you taking an entire quarter or more for you to analyze, figuring out, hey, what does my scope need to look like? When you have a team like the pod ops team that's sitting next to you though, for an entire year, you can sit there and start off agilely and iterate on things that need to change in the cluster based off your workloads. So we remove the risk of failure. Never had a failed project. If we work with you, your workloads are going to run. Remove vendor lock-in. We're helping you understand how to build this in a way that you're not locked into specific vendors. So as this world dynamically changes, you're there to be able to also make choices on what you want to do and reduce the team stress. You're not getting called at 3 a.m. when something's going on. We're letting you know how we solve that problem after the fact. Sev 1 issues, we're there right by your side with all of the help that you need. Our team is 24/7, 365, running clusters all around the world for our clients. What you gain is you gain the knowledge and at a reduced cost. The cost of resources are very high, and then the cost of maintaining those resources. We have a way that you can get all the knowledge you need and reduce your cost. And in today's market, everybody's trying to find a way to reduce their cost while they're modernizing. We have the right solution for that. So you take a look at here, 0 to confident in days. We include the subscriptions for you, 12-month commitment, subscriptions for the platform, scale on demand monthly, run anywhere, on-prem, public cloud, SaaS, hybrid. We run some in Power, application deployment support, dynamic tuning. So your application team understands what's happening with their applications, run it hybrid. We also provide DR and backup. We actually have some more advanced version of DR and backup that's at an additional cost. So we can walk through what those different options are for you. This is based off of a minimum build of 48 virtual CPUs. Remember, you can get a lot more out of your infrastructure when you're moving to a container environment. So that's a prod and non-prod environment. So your first 48, don't get, so you guys know the show First 48. Yeah. So don't get murdered. Or if you're getting murdered on price, you got to come to Crossvale for your first 48. So 24/7, 365, it's $19.99 an hour. That includes subscriptions. You want to add more virtual CPUs, each 48 virtual CPUs after that, $449 an hour. 8x5, you just need business hours coverage, don't need weekends and evenings. First 48, $49.99 an hour, includes subscriptions. Add more virtual CPUs, at 48 virtual CPUs, $14.99 an hour. So very cost effective. You go out there and you take a look at, hiring consultants, you might be quoted $200 an hour, $300 an hour. We're doing the entire thing for you for $20 an hour, or if you're comparing 40 hours a week, $49.99 an hour. Much more cost effective with the team that this is all they do. They specialize in this. There's a special offer today also. If you go to crossvale.com and go to the contact sheet, which here's the link to it, PodOps Pro is awesome. Send that to us and we'll get you signed up for $15K in free port work. So your DR and backup for your first year will be included up to 6 nodes. So that's a $15,000 value there to have Portworx working in your environment for DR and backup, which is one of our advanced services. So you got to sign a 2-year commitment to take advantage of that solution. Your first year is free, and we can help work through that. So no obligation. If you go to the contact page and send us a PodOps Pro is awesome. We can reach out to you. If you don't, if you buy, then you get to take advantage of this, and we can have our sales team reach out to you to help you through that process. Top 10 reasons to standardize on PodOps OpenShift. Guaranteed success. No interviews for SMEs you don't know how to hire. No late night deployments for ops teams. Proactive maintenance reduces downtime. We bring the proactive maintenance that we've already built. No marathon support calls with Red Hat. We do that for you. If there's a bug, we probably maybe already solved it with one of our other customers, and we're going to your environment to help you solve it before you see it. Ask an expert that knows your environment. Our team understands your unique environment. You're not asking questions about, asking somebody to help you that doesn't know what's going on in your environment. Operational integration into your ITSM. Run this just like it's like we're your own department. Mentoring is more effective than training. 12 months, we're with you right along the way, mentoring you to understand how to make dynamic decisions. Our team learns from other environments as well. So we're doing it in a bunch of other places. So as things come up, we learn, and then we pass that learning on to you. We do it cheaper and better, cheaper with better outcomes than you can do it yourself, guaranteed. So our brand story, passion, trust, delivery, that's what we stand for. We're really passionate about this, and we build trust with our customers so that you feel like we're part of your team. I will open it up if we have any questions. Laura, is there any questions in the chat? So question, $19.99 per hour versus $24.99 an hour for 8x5. The difference on that is there is 2,080 hours in a year for 8x5, and there is 8,600 hours for 24/7. So that's why you see a difference in price, because it is spread out across a different amount of hours. So the 8x5 actually annual price is cheaper, comes in about 40% less than what the 24/7 pricing is on that. Remember, also subscriptions are optional. This is quoted with the subscriptions. If you already have your own subscriptions, I can quote you just the maintenance, the pod op service that doesn't include the subscriptions. If you haven't bought your subscriptions, you'll probably want to buy it through our service because they're going to be most cost effective. All right, well, thank you, everybody. If you have any questions and you want to reach out, you can reach out to the Crossvale team through the contact form, whether they're technical or whether there's something related to our service. We can get back to you and help you through your situation. The scenario, we don't do everything for everybody, but what we do here, we do exceptionally well. This is a key part of what we do, and we're best in the world at this. Thank you, guys, everybody. Have a great day.
Thanks, guys. Bye.